Hello everyone, welcome to this video. This will be a quick one, very practical on managing file paths. This is particularly important for those of us who are data scientists or regularly working with different data files. When you're working with different data files, you have to provide a path or address to the file that you're working with. This can be the input file or the output file. You need to provide a path where you want to save the file. So if you are going to share your code with other people, or you're going to run your code in different environments, your own computer might be a Windows, you might be running the code on a virtual machine that is running most likely Linux, or you might be sharing your code with your colleague who is using a Mac computer. So different operating systems have different conventions when it comes to managing file paths, and this is the source of problem. Because very often, earlier, we used to use file paths were often hard-coded as strings. And if you hard-coded your string for Windows, then you would have a problem on Linux, for instance. On all Unix-based operating systems, such as Linux or macOS, directories are separated by forward slashes, while Microsoft Windows uses backslashes. So this is an example of a situation that you will run into trouble. So if you don't handle your file path and you share your code with someone, they will get an error and they have to make updates to your code. Luckily, since Python 3.4, so it's not a long time ago, well, it's been a few years already, there exists a built-in module that eases much of the hassle with managing file paths. The name of the library is Pathlib. It provides an abstract layer on top of the actual operating system file path that is consistent across computers, and that's a great thing. So now we get started with this and see how we can use this in practice, and hopefully we get used to this because this is a good coding practice, especially for data scientists. So later on, we will be loading a dataset coming from weather.gov. It's some GIS data of the borders, vector data on the borders of the states in the United States. So how do I do this? I start by importing the library. As I said, this is a built-in library, so it is easy to import. You don't need to install it unless you're running a very old version of Python. So I import Pathlib, which is the name of the library. Then I create an path object using pathlib.path function without passing any argument. So a pathlib.path object can be initiated with a file path as a string when created without an argument. And it refers to the directory of the script or notebook file that you're using right now. So let's just run this. As you can see, I'm using a Windows machine, and that is reflected in the file path. So far, this path is not checked against the actual directory structure, but we can resolve it to convert it into an absolute path that we can use for different purposes. So let's define the path again, using the same function. Next, I'm going to resolve this path to convert it into an absolute path. So path.resolve, and then let's just print it to the screen to see what we have. So I'm on a Windows machine, and you can see this is the path to the folder from which I'm running this script or this notebook. So the path object has a number of properties and methods that might be useful to you. You can check for more details on the documentation, but I will just show a couple of them. So path that exists can be useful if you want to make sure that a path actually exists, for example, before saving a file, to make sure that you don't save it in the wrong place or get an error that the directory doesn't exist. It will return a Boolean value to you. In my case, it's true because the directory exists. If you have a path and you want to make sure if it refers to a directory, you can use isDire or isDirectory method, And again, it will return you a Boolean value telling you whether this is pointing to a directory or not. There are a few other things that you can use. For example, you can delete a path if it's a file, or delete if it's a directory, or you can rename files or directories using path.rename or path.unlink or rmdir or remove directory. I'm not going to do them here, but these are also available in case you need them. So now we want to get a bit more practical and see how we can handle paths effectively when working with real data. So I will start over. So this is the kind of cell that I usually start my work with. So if you follow my other videos, you see that when working with GIS, I often start like this. So I import my library, Pathlib. Then I'm going to define the path to my data, because very often I save all my datasets into a folder next to my script, and I want to easily define the path to the data directory so I don't have to retype the thing or worry about how to handle file path every time. So I create a new variable called notebook path. So I'm deliberately using all capital letters here. This is a good practice in Python. If you have a variable that should be treated as a constant, so whoever is working with my code, I don't want them to update this. I want them to treat this as constant. It's a good coding practice to write them in capital letters. And the reason is that in Python, we do not have constant variables. For example, in C language, we can define a variable as a constant and then it's all fine. But in Python, we don't have. So if you want something to be treated by the reader of your code as constant, then you should write it in capital. As I said, it doesn't really change anything in practice. It's just a good coding practice. So pathlib dot path. Then at the same time, I just resolve the path so it becomes an absolute path. And then I will show you the structure of my data folder. So I'm here now, the file handling folder. Inside it, I have another folder called data. So I want to go inside that folder because that's where my data actually is. And I am going to show you some shapefiles. And that shapefile is actually inside this folder. So I have to go first. I have to navigate 2 directories down from where I am right now. So I'm going to define the data directory, data directory, and it is from where the data path is. I will just copy the name of it. It is in data. So this is how you navigate to another folder, which is inside your folder. Okay, I want to actually treat this as a constant, so I will write it in capital letters. So let's just do this. A data directory. So it is now defined. So I'm inside this folder. If you want to go, so this is how you can go inside a directory that is under your directory. If you want to go back, then you can just write path.parent, not with capital letters, path.parent. And this takes you one step back, so without brackets. So I'm not going to do this now, but if you need to go one folder back, this is how you can do it using path that you have defined before, dot parent. So now that I have defined the path to my data folder, I'm going to next load the data. So I'm going to work with geospatial data. I have already installed my libraries. So in case you haven't, if you don't have GeoPandas installed, you can just use pip install GeoPandas. So this is what we need for loading the vector data, and also for visualizing it we are going to need Matplotlib. I have them installed, so I won't run this, I just leave them as comments. So I will import GeoPandas, and then I'm going to just load my dataset using GeoPandas.read file function. So it's read_file. In another video we will learn how to work with GeoPandas, but that's not the purpose of this video right now. So I have already defined my data directory, which points to the data folder, but remember, my data is still inside another folder, so I'm going to write that as well. So s_03 mr26, and after that when I'm in the right directory, I want to open this shapefile, which is named s_03 mr26.shp. So I will just run this. My data is loaded. So next thing, to show if this worked correctly, I'm going to just plot my data to see if the data is loaded correctly. Okay, so now the data is plotted, I can see the United States and the borders or the polygons showing different states. We are going to revisit this topic of GeoPandas and visualization later on and see how we can produce better maps, but that's not the point here. The point is that we use Pathlib to efficiently import, to efficiently handle our file path, and we use that to import our data, and we check that if it is correctly loaded using plotting function here. See you in the next video.